The promise that knowledge brings with it has tantalized mankind throughout history, ever since we were thinking beings, able to stand on two legs and learn to make fire, ever since the first cave paintings were drawn and the first songs shared humanity, we're destined to develop and create civilizations. As we grew and developed as a species, over centuries and millennia, we cultivated ourselves physically, spiritually, and mentally. Millions of years of evolution have brought us to where we are today. Today, humanity has been able to bring answers to ancient questions that the first philosophers and scientists could not find answers to, that have been erased and answered one after another by the scientific community over the years. Little by little, fewer and fewer things seem impossible for mankind. Communication is immediate, diseases are beginning to be cured, and transportation, which used to be worth lives and time, is now convenient and fast. Still, there is always a but. We know how humanity was born. We know what came before it. We discovered the birth of our planet and the birth of entire galaxies. But really, when did time begin? If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. Throughout history, theories have come and gone. One of the most popular and scientifically accepted is the Big Bang theory. Knowing that the universe is constantly expanding, Lemaitre proposed the idea that at some point in time, the entire universe was conceived at a single point. From this point, the universe expanded and stretched to the magnitudes we know. It was not until years later that the astronomer Edwin Hubble was inspired by the priest's idea. He discovered, moreover, that there are galaxies moving away from us, and the farther away these galaxies are, the farther they move. Simply put, it was expanding. With the certainty that there are galaxies moving away faster and faster, he was able to reaffirm the theory already put forward by Lemaitre. Subsequently, it was defined that before the Big Bang took place, there were only hot and tiny particles mixed with light and energy. It was not until everything expanded that everything began to cool down, giving rise to the particles settling down, and atoms were born, which grouped together, and after millions of billions of years, a multitude of galaxies have been born and have perished. At the end of 2021, the James Webb Space Telescope, the most complicated and expensive telescope ever built, was launched in space, working with the analysis of infrared light waves and located more than 1 million kilometers from our planet. The James Webb Space Telescope's reach is unparalleled. Its ability to capture photographs and process data is extremely accurate. Neil deGrasse Tyson once mentioned that because of how it works, the farther away the telescope looked, the farther back in time it could also see. The James Webb Space Telescope was originally expected to help confirm the Big Bang theory. However, the first photographs it took and made public, while captivating, also put something in evidence. In the published images, it is possible to find galaxies that are incredibly smooth and small and old. While you may wonder why this has to do or how this influences the Big Bang theory, we ask for some patience. Everything will be resolved below. In order to be sure that the universe is constantly expanding, there must be some kind of optical illusion. However, in the photographs, objects that should be at a greater distance decrease in size. Actually, beyond a certain point, these galaxies should appear larger and larger. This is because, theoretically, the light from these galaxies has left them just when they were closer to us. The scientists and specialists working on translating the data and creating the James Webb images cannot hide the fact that they show smaller galaxies. Similar images taken by the Hubble telescope show several inconsistencies with their sizes. In the James Webb photographs, the same galaxies appear smaller. In addition, these younger galaxies have a redshift 2 to 3 times larger. In one of the pictures taken by the Webb, it is possible to see a large number of galaxies with exactly the same size. This would show that the universe is not really expanding, and the redshift is proportional to the distance. However, according to the Big Bang theory, these galaxies should be intrinsically smaller to compensate for the optical illusion. It is also possible to appreciate that there are galaxies that look smooth. If so, there should be so-called Mighty Mouse galaxies, galaxies that collide with each other to give birth to another galaxy, merging as it disperses. As a result, these galaxies should suffer from some form of derangement, a kind of scar that can be studied and analyzed. However, photographs presented by the James Webb Space Telescope demonstrate extremely clean spirals, about 10 times cleaner than science expected. This is another strong blow to the Big Bang theory, proving that galaxy mergers are particularly rare. Because they are so rare, it is impossible for these galaxies to become very large due to the lack of such a merger. We can therefore understand that galaxies that are immense have been so since their inception. Finally, capturing such old galaxies proves another fallacy. Galaxies over billions of years old have been seen almost as old as the Big Bang would be. The only way for the James Webb Telescope to affirm the Big Bang theory in this sense would be for it to see fewer and fewer galaxies the farther away it sees, since they would be so old that they have been completely consumed, being able to capture a stage known as the dark stage of the cosmos. Just by looking at the first available images, it is possible to find at least 100,000 more galaxies than predicted by theoretical scientists dedicated to infrared displacement greater than 10. To put it simply, and with a question, would it have been possible for so many galaxies of such a size to form in such a short time? Many believe this to be completely improbable. There is another theory, however, that can explain all the failures and inconsistencies of the Big Bang, the plasma filamentation theory, which has been around for the last 5 decades. Simply explained, this would be the process in which electric currents and the magnetic fields they create attract the plasma in the interlocking system of filaments seen at all scales of our universe. Plasma filamentation is one of the basic processes that have been able to bring about the creation of stars, planets, and galaxies, as well as other structures. Galaxies are formed from large clouds of gas and dust that are gravitationally attracted to each other. When the cloud of gas and dust becomes dense and massive enough, it can collapse under the influence of its own gravity and form a protostar at the center. The protostar begins to fuse hydrogen atoms in its core, which releases a large amount of energy and gives rise to a young star. In the process of star formation, plasma filamentation can contribute to the collapse of the cloud of gas and dust into a protostar. Plasma filaments can act as support structure to keep the gas and dust cloud gravitationally bound and can provide a way to transfer energy and momentum within the cloud. Once a star is formed, it may have a protoplanetary disk around it, composed of gas and dust, from which planets can form. Plasma filamentation is not directly involved in this process, but can influence the dynamics of the gas and dust in the protoplanetary disk, which can affect planet formation. Moreover, this theory plays a crucial role in the attempt to create fusion energy artificially. Will this really be possible? Only time and scientific studies will tell. It is possible that another theory about the birth of our universe will be born. But about that, for now, we can only speculate, considering that nothing has been officially accepted. And you? What do you think about it? Don't leave without letting us know in the comments box below. Don't forget to subscribe to the channel and activate the comments bell to stay tuned for upcoming content and more news on the subject. That's all for today, and we hope to see you in the next time. Thank you so much for watching the video, and see you then.